Life cycle of a star. Phase 1, FORMATION. The life of a star begins in a nebula, a massive cloud of gas and dust. Under the right conditions, such as those created by a supernova or a collision of two clouds, the cloud will collapse under its own gravity, creating areas of higher density. The heat generated by the protostar causes the gas and dust in the surrounding cloud to collapse onto it, increasing its mass. This process continues until the protostar reaches a critical mass, at which point it will ignite into a main sequence star. Phase 2, main sequence. The main sequence is the longest and most stable phase in a star's life. During this phase, the star converts hydrogen into helium through nuclear fusion, generating energy that provides the pressure necessary to counteract the star's gravity. The temperature and luminosity of a main sequence star are determined by its mass. Stars on the main sequence will continue to burn hydrogen for billions of years, until the hydrogen in their cores is depleted. Phase 3, red giant or red supergiant. Red giant or red supergiant. It depends on its mass. High massive star or normal star. As the hydrogen in a star's core is depleted, its core will begin to contract, increasing the pressure and temperature. This will cause the outer layers of the star to expand and cool, turning the star into a red giant or red supergiant. During this phase, the star will begin to burn helium in its core, producing carbon and other heavier elements. The process of helium burning will eventually cause the star's core to contract even further, increasing the temperature and pressure until it reaches a critical point. Phase 4, planetary nebula or supernova. When the temperature and pressure in a red giant's core become high enough, the outer layers of the star will be expelled, creating a planetary nebula. The expelled material will expand into space, creating a beautiful and complex structure of gas and dust. The star's core will be exposed, becoming a white dwarf. In the case of a red supergiant, when it runs out of fuel, its core collapses and results in a supernova, a powerful explosive event that causes the star to increase in brightness before slowly fading away. There are two types of supernovae, Type 1 and Type 2, and they play a crucial role in the evolution of the universe. The explosive energy released by a supernova can enrich the interstellar medium with heavy elements and trigger the formation of new stars and planets. Phase 5, white dwarf, or neutron star, or black hole. A white dwarf is formed by a normal star's planetary nebula, and it is a small, extremely dense star that is no longer capable of producing energy through fusion. In the case of supernova, it can result in the formation of a neutron star or a black hole. Neutron stars are extremely dense objects that are formed when a massive star collapses under its own gravity. Black holes are regions of spacetime where the gravitational pull is so strong that nothing, not even light, can escape. Phase 6, white dwarf into black dwarf. The final stage of a star's life is the formation of a black dwarf. Black dwarfs are the remnants of stars that have exhausted their nuclear fuel and have cooled down to the point where they no longer emit any light or heat. They are thought to be the end state of the evolution of most stars, including the Sun. In conclusion, the life cycle of a star is a fascinating and complex journey that begins with its birth and ends with its eventual death.